Think about what you're doing right there. Your hand is touching matter. It's matter touching more matter, really. And what is that thing that you're touching? Is it wood? Is it plastic? Is it fabric? Think deeper than that. What is it? Is it atoms? But what are those? Think about it. Unequivocally, what is it that you are touching? It is matter. We know that. But what is matter? That's what we're going to figure out today. So let's kick into it. To define something that is literally everything around us, that is the hubris of science laid bare, I'm pretty sure. Matter is this huge all-encompassing thing, and you're surrounded by it all the time. But at some point in ancient Greece, a guy named Thales looked at the world in 6th century BC and thought, what is this stuff? But in Greek, I don't know ancient Greek, so we'll just assume that he has a weird Midwest accent. Thales was a famous natural philosopher, which is what we would call scientists today. They would be called natural philosophers in ancient times. And my philosophy boo Thales, he was famed. He was well known because he had all of these cool, interesting thoughts. He was friends with a bunch of other Greek philosophers, and he was the first recorded human to accurately predict a solar eclipse in advance. Nobody really knows how he did it or even how accurate it was, but he was able to predict it. And that was a pretty big deal. It meant that he knew something and that people would be able to listen to him. And so when he said, what is this stuff around us? What is this stuff that we're touching? What is this rock made of? Not just rock. What is deeper than that? People listened. And Thales said there must be some fundamental form to the cosmos, some organization. Which is kind of shocking. If you believe a deity created the world, there doesn't necessarily have to be fundamental form, right? Beyond what the deity envisioned. All of existence, Thales thought, though, must have been made of something. Something must start and be at the base of everything around us. Aristotle said that Thales was the first to think about this, the first one to look into it. And he explained it as natural phenomena, not with gods, but with observation and testing. Thales invented the scientific method, but Thales wasn't perfect. Like, he sounds like a pretty badass dude, but he's not. Because he was all like, matter is what makes up nature, but matter has a base substance, and that is water. Not quite right. Thanks Thales on that one. He believed everything started as water and then turned into everything and then went back to water. Which, if you think about living beings and living things, that does kind of make sense. You have a desert, you put water there, you can get plants and you can get life. And then you take away the water and it goes back to desert. But Thales wasn't really thinking as deeply as maybe he could. And that's okay, Thales, my boy, but it's pretty close. You know, cells are made of water. The earth is 70% water. Water is very important, but it's not the basis of all things, right? That's not what matter is. If anything, it's just yet another type of matter. But it kind of, to not make a pun, but it kind of doesn't matter if Thales was right about it. What matters is he was thinking about it. Thales was asking this question and starting the fire that Billy Joel sings about, right? Wood is made of something smaller and smaller. If I take wood and I break it, and then I break that, 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 how small can I make it? That's a great question. This question kind of hung in the air for a while until we discovered cells. The tiny bits that make up all living things. Cells were discovered in the late 1600s by a guy named Robert Hooke with a compound microscope that he himself designed. And in his book Micrographia, which was published in 1665, it was a bestseller, he was able to show these tiny, tiny things with his newly invented microscope. And even though there were no YouTube commenters at the time that made fun of how he looked or sounded, one guy did call him, quote, a sot that has spent 2,000 pounds in microscopes to find out the nature of eels in vinegar and mites in cheese. So even though he was essentially discovering how the world was put together, there's always going to be haters. It just happens. Eventually, we discovered not just cells, but that cells were made of something as well, and that is atoms. By the way, sidebar, atoms were actually first thought of in the 3rd century BCE by Democritus, and he was asking if we could break something up and then break that, kind of like I was talking about with the wood. And it was a philosophical question, pure hypothesis, but it was neat that in the 3rd century BCE, people were thinking about it. Anyway, atoms were not discovered until 1803. A Quaker science bae, John Dalton, looked at it and said, yo, there's got to be an indivisible, indestructible atom at the basis of all of this stuff. Dalton, you weren't quite right, but you were close, man. You were getting closer than anybody who'd been before you, right? Not all correct. You can divide an atom, but still. Now we're down to particles, right? We got particles inside of atoms. They've got little bits of atoms. The electron was the first one of those to be discovered. Main squeeze J.J. Thomson discovered the electron in 1897, not actually that long ago. Then protons were discovered in 1911 in a paper by Bo Ernest Rutherford, and he let radioactive stuff decay, and it was hitting this thing that was a zinc sulfide sheet. So you turn the lights off, you let radioactivity decay, and as it hits the zinc sulfide sheet, it lights up with little bits of light. So he told his assistant to look at it. His assistant's name was Geiger. You might recognize that if you're in the radiation game. Geiger was counting all of these little bits of light, and he was like, can't we invent something that does this? He did that later. Then in 1964, we discovered quarks. At this point, we'd already smashed the atom, and yet we didn't know what was inside of it. We just knew we could break it. So we started breaking them again and again and again, akin to smashing cars together to figure out what's inside of them, right? And we eventually, in 1964, discovered that they were made of these little bits called quarks. Quarks make up atoms. And just without getting too detailed, a proton, for example, is 2 up quarks and 1 down quark. Quarks have spins and also colors and flavors. It's real weird. We can get into that in a minute. They also then later discovered leptons and fermions and antiquarks and all sorts of other little bits inside of these atoms by smashing them together. Again, like smashing together cars and being like, hey, there's a seat in here. That's pretty cool. What does that seat do? That's kind of what we're doing with atom smashers, just real tiny. And what some of these little bits of atoms do is actually still a mystery. A Scientific American article said, quote, up quark, down quark, and electron are really the only particles necessary to build a universe. So why do they have so many cousins? In fact, when we discovered the muon, which is another particle inside of atoms, one of the physicists was quoted very famously as saying, muon, who ordered that? Because we didn't need it. We didn't need a muon to make a universe, really, according to some physicists. So why do we have all these little bits inside of atoms? We don't really know. But again, to bring it back, this is all matter. It's around you all the time, and we still don't really know what it is. Also inside of atoms, you could categorize them more as forces, are things like gluons, which gluons comes from glue. It sticks things together. That's a strong force. There's photons, which are electromagnetic. They have no mass, but they're pretty cool. There's also famous Higgs bosons. They're the things that give us mass. That's a weak force. There's also the yet undiscovered but theorized graviton that interacts with gravity and gives everything gravity. And we're still finding all of these little bits. We kind of know that they fit together based on all sorts of different hypotheses and theories that have been proven and tested, and yet we still haven't discovered them all, in part because it's real small. And you can only smash so many atoms together until you find all the little bits. While I was putting this episode together, in February of 2018, we discovered the Autoron, which was theorized in the 1970s based on the frameworks that had been laid out in hypotheses, and they finally smashed it out of protons in 2015. The preliminary evidence is there. They still haven't officially discovered it, but still it's pretty exciting for 2018. The Autoron is named that because usually these little bits of particles come in pairs, and this one came in threes, which is pretty cool. So to wrap it up, what is matter? Matter is literally just the stuff everywhere around us. It's distinct in that it's not stuff. That's kind of it. Matter is everything, and things that are not matter is nothing. I know it's complicated, but this is how physics works. And I know we didn't go all the way to the bottom, right? What's below a quark? This is when you start to get really weird. So what are quarks made of? What are muons made of? What are leptons and fermions and all these things made of? That's when you get to superstring theory. You've probably heard of this. It's really complicated. But according to this, if it's right, all of these little particles are made of strings. Not like literal like shoelaces, but, little strings of energy. And they're identical. The strings vibrate at specific energies, so all electrons, for example, have the same resonant vibration. And the vibration energy determines what a particle is. So a proton has a different energy that attracts the electron. Get it? A neutron has a different resonance that doesn't attract either of them. But they're all just vibrating strings, filaments, the substance of the universe. So according to some of the nerdiest, smartest people on Earth who've been working on this for hundreds, if not thousands of years, to answer Thales' original question of what is all of this stuff around us, what is matter? Simple. It's a one-dimensional vibrating string of varying energies that can sometimes be loops. That's it. The question is now, what do we do with this? What do we do with matter? For that, you'll have to come back next week. Thanks everyone for tuning in to Seeker Plus. I hope you enjoyed it. I know this one went pretty fast to get through all of that matter stuff. Next week, we're going to talk a bit more about matter and all the different states of matter. It's going to be really exciting. And then the week after that, you're just going to have to stick around and find out. So make sure you subscribe so you get those episodes and all the other episodes that Seeker is putting out every day, our short docs, Science in the Extremes, Wild Sex, Spacecrafts. We've got a lot coming out for you. So thanks so much for watching. You can find us on Twitter @Seeker. You can find me @Trace Dominguez. We'll see you next time.